Calculate the volume in ml of 2.000 molar HC₂H₃O². The student needs to prepare 100.0 milliliters of 0.115 molar HC₂H₃O². Describe the procedure the student should use to prepare 100.0 milliliters of 0.115 molar HC₂H₃O² using appropriate equipment selected from the list below. Assume that the student uses appropriate safety equipment. 100 milliliters beaker, 100 milliliters graduated cylinder, 100 milliliters volumetric flask, eyedropper, 500 milliliters wash bottle filled with distilled water, 2.000 molar HC₂H₃O² in a 50 milliliters buret. M1V1 equals M2V2. Vi equals 0.115 molar. 100.0 milliliters / 2.000 molar equals 5.75 milliliters. 1 point is earned for the correct volume. Use the buret to deliver 5.75 milliliters of 2.000 molar HC₂H₃O² to the 100 milliliters volumetric flask. Then add distilled water from the wash bottle to the flask, adding the last few drops with an eyedropper, until the volume of liquid in the flask is at the calibration mark. 1 point is earned for dispensing from the buret. 1 point is earned for diluting the solution to the calibration mark of the volumetric flask. Using a pH probe, the student determines that the pH of 0.115 molar HC₂H₃O² is 2.92. Using the pH value, calculate the value of Ka for HC₂H₃O². Calculate the percent dissociation of ethanoic acid in 0.115 molar HC₂H₃O². pH equals 2.92 gives H3O+ equals 10 to the power negative 2.92 is equal to 0.0012 molar. Ka equals H3O+ C₂H₃O² minus / HC₂H₃O². Since H3O+ equals C₂H₃O² minus, then Ka equals 0.0012, 0.0012 close parenthesis divided by open parenthesis 0.115 minus 0.0012 close parenthesis equals 0.0012. To the power 2 divided by 0.114 is equal to 1.3x 10 to the power negative 5. 1 point is earned for correct conversion of pH to H3O+. 1 point is earned for a value of Ka consistent with the student's value of H3O+. Percent dissociation equals C₂H₃O² minus / HC₂H₃O². 0.100 is equal to 0.0012 / 0.115, 100 equals 1%. 1 point is earned for the correct percent dissociation. Write the balanced net ionic equation for the reaction that occurs when HC₂H₃O² and NaOH are combined. HC₂H₃O² plus OH minus gives C₂H₃O² minus plus H2O. 1 point is earned for the correct equation. Calculate the molar concentration of the NaOH solution. From the pH curve, the equivalence point occurs at 14.0 milliliters. 10.0 milliliters asterisk, 2.000 moles HC₂H₃O² / 1,000 milliliters equals 0.0200 moles HC₂H₃O². 0.0200 moles HC₂H₃O² asterisk, 1 moles NaOH / 1 moles HC₂H₃O² equals 0.0200 moles NaOH. 0.0200 moles NaOH / 0.0140 liters solution equals 1.43 molar NaOH. 1 point is earned for determining the moles of acid. 1 point is earned for determining the molar concentration of the base. Explain how the student can estimate the value of Ka for HC₂H₃O² using the titration curve. At the half equivalence point, 7.0 milliliters, the pH of the solution is equal to the pKa of the acid. The antilog of the negative pH is equal to the value of Ka. 1 point is earned for a correct explanation, numerical explanation not required.